Okay, let's pick up where we left off. We had described the slope as either positive, negative, zero, or undefined. Now we're going to calculate them. There's a formula and it's written above. I like to introduce it right here. Let me go back up. Here is the slope formula. And I'm actually going to rewrite it down here so I'll be closer to what we're doing. It is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We will see one of each of the types of slopes that we drew above. A positive, a negative, a zero, and an undefined. So you'll get to see what they look like algebraically. Now, where do these subscripts come from? Where do the little 2 and little 1s come from? Here. Every point has an x and a y in it. But this is our first point. Why? Because they wrote it first. So that's x in the first point, y in the first point. That's x in the second point, y in the second point. Now you know where the subscripts came from. Let's plug into our slope formula and solve. When I plug in, I want you to make sure that you use parentheses around the y sub 2 minus y sub 1 and the x sub 2 minus x sub 1. Why? Because occasionally you'll have a double negative and I don't want you to lose it. 2 minus 4 is negative 2. 4 minus a minus 3. Wait a minute. Minus minus. That's a double negative. So it's actually a plus, isn't it? Negative 4 plus 3 is negative 1. So our slope is 2. There's our positive slope calculated for you. Let's do it again. First thing on number 4 I'm going to do is ask you to label your points. This is x in the first point, y in the first point. X in the second point, y in the second point. And plug in. Y sub 2, and remember, put parentheses around anything you're plugging in, minus y sub 1 over x sub 2 minus x sub 1. Here's another double negative. You're going to make it a plus. 3 plus 2 is 5. 7 minus 7 is 0. That's one of our special slopes. Remember, if the 0 is underneath, it is undefined. Let's do 5 and 6. And again, pause the video if you need to and try it on your own. This is x in the first point, y in the first point. X in the second point, y in the second point. And we're going to plug in y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I see a double negative. Let's fix it. And clean up. Negative 2 minus 4 is negative 6. 1 plus 3 is 4. That reduces to a negative 3/2. There's an example of our negative slope. Let's go on to number 6. Label your points. X in the first point, y in the first point. X in the second point, y in the second point. And plug in. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Ooh, a double negative. Clean it up first. So now we have negative 5 plus 5, which is 0, and 1 minus 2, which is negative 1. 0 over any number is 0. Now, interesting thing, and I want to go back to our picture and show you. If you have a 0 slope, it's a horizontal line. If you have an undefined slope, it's a vertical line. All right, the concept of slope to solve a given equation. If a computer was worth $2,000 in 2019 and only $800 in 2022, find and interpret the average rate of change in the value of a computer for over the 3 years. Now, if you go back to the very beginning, and I didn't do a very good job there, let me go back. When they describe slope to us, Another thing that they called it, now we're going to actually see all of these. Oops. Rise over run, the change in y over the change in x, and here's the other thing, the average rate of change. This is one of the applications of this slope, to find the average rate of change. And the way you do it is you're going to write down your 2 points. They told us that the computer was worth $2,000 in 2019, but only $800 in 2022. We know it's depreciating, but how quickly and how often, how much did it do it in 3 years, from 2019 to 22? So I'm going to write down, I'm going to write down that in 2019, this computer was worth $2,000. This will be our X, this will be our Y. And in 2022, the computer was worth $800. I want to see the average rate of change. I'm labeling my points already. Okay, let's plug into our slope formula. We're going to get y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's see, when I subtract, we're going to end up with negative 1,200 over 3. So negative 400. Now let me explain this. Our computer is depreciating by 400. How do I know it's depreciating, that it's losing value? Not just because I saw it here, but because my slope is negative. I can say the price is decreasing. Decreasing by $400 per year. That's the average rate of change that is being described in that example. Very cool. Now let's look at the rise over run method. Super cool. Okay, this is the last thing we're going to do. They're going to give us a point and they're going to give us a slope, and believe it or not, we should be able to draw this just based on that. Now, the slope is actually like our GPS. So with the rise over run method, the top number in our slope, and by the way, if it's not already a fraction, it's always an advantage to write your slope as a fraction. The top number will tell me how to move up and down, depending on the sign. If it's a positive number, you go up. If it's a negative number, you go down. The bottom number will tell me how to move left or right. If it's positive, it goes to the right. If it's negative, it goes to the left. Don't overthink it. Now, that's our rise over run in symbol form. Okay, so let's look at our first equation here. If you're graphing it using this rise over run method, they're going to give you a point, negative 1, 1. Let's go there first. That's our starting point. From there, I want you to use the slope, our GPS, to tell me how to move. The 2 is positive, so I'm going to go up 2. And the bottom number is 3, so I'm going to go to the right 3. I'm going to start at our given point, our starter point. I'm going to go up 2 and to the right 3. Make a dot. And then you're going to do it again. I'm going to go up 2 and to the right 3. And you can do it as many times as you like. Up 2 and to the right 3. And now you have an equation graphed using the rise over run method. Let's do it on this one. Now, anytime that I have a negative fraction, you can bet I'm going to rewrite it with the negative on the top. We've talked about it this semester, haven't we? I'm going to start at the point 0, 3. That's our starter point. From there, I'm going to go down 1 and to the right 2. Why? Because the top number tells me how to move up or down depending on the sign. If it's positive, it goes up. If it's negative, it goes down. The bottom number tells me how to move left and right. Since it's positive, to the right. So starter point, we're going to go down 1 over 2. Do it again. Down 1 over 2. down 1, over 2. You can do it as many times as you like, but you really only need to do it once. But I recommend that you do it a few times so you can get a good feel for the line. Now our two special lines, remember what the slope looked like. Slope of 0 was slow and steady, just straight across, right? Didn't change. Undefined. Remember, if you drive your car up and down, what are you at the bottom? You're in flames, right? You blew up. So an undefined slope is always going to describe a vertical line. And the slope of 0 is always going to describe a horizontal line. Now let's see here. I'm going to go to the point -3, 1, and I'm going to draw a vertical line in. Now, did you notice that with the vertical line, every single point is going to have an x of -3? That's actually the equation of the line. Kind of neat. Same thing over here. Go to the point 1, 4. I'm sorry, 1, -4. 1 down to -4. And we know it's a horizontal line because we know what those look like when they have a slope of 0. And did you notice, if I had drawn it better, stay on the dots, Alma. There we go. Okay. Every point is going to have a y of -4, and that's the equation there. All right, I'll see you in the last section.